Hello everyone. Assalamualaikum. So I finally got some time to record this video uh, on a use case that I completed over the weekend. I mean last weekend. So the idea that I got to create this project is based on a few of my the people I know working on a big organization where they themselves are non-technical. So whenever they need to retrieve data from the database for their own analysis or uh, some sort of project they are working on, for proposal or something, then normally, they will have to go through an IT data guy. So, they have been, they're making jokes about, how sometimes how late the data that requested they receive. And normally it would take about like 2 days to 1 week before they actually receive the data. So this is probably because the data guy is too busy, or I don't know what, but it looks like it's not really a straight forward process. So this caused me to ask the question whether with AI now can we create something so that the non-technical can actually retrieve the data on their own directly from the database. Right. So again, the tools that I'm going to use to create this is using Cursor IDE for the programming, Aider for the coding assistant, and I'm using again the Cloud 3.5 Sonnet, and I'm also going to use OpenAI structured output uh, to ensure that the data uh, responded by or from the database is in a consistent structured output format for me to use in the downstream process. Right. So the idea or the process flow of this app is like this. So basically, the non-technical when they interact with the application, they can send in the first user request, the intent of the kind of data that they want. And then the AI knowing or expose the table structure, from a database table or a schema manager, uh, will then ask, clarification or clarifying question so that, uh, when it finally satisfied knowing that it can generate the final query, then it will then just do that. But before that, it will first again ask the user whether this is exactly what they want, and if the user confirm, then again the AI will generate the query and then run it through the next process. So uh, then the AI will generate the query. And then from this process, they will then run the query using the SQL runner or SQL executor manager. And then there will be like two result from this process, whether the query have error, uh, and then they will pass back all this error and all the conversation history back to the previous AI instance to think about how to fix that SQL and then run it again. And if successful, then AI will generate the data or the data analysis. Then from the response of the data coming from the SQL manager, then format it and return this data or this analysis back to the user, right? So uh, I'm also thinking that this system can also be enhanced if we can actually do some sort of RLHF, which is reinforcement learning with human feedback, and tie that with some sort of a RAG system, so that we can also feed the successful SQL generation from previous user query uh, to provide us more context when the AI is trying to generate SQL for this process. But for this project, this I'm not going to show. I didn't do this. I'm just thinking that this will also be possible. Right, so I call this system data self-service because technically it's like a data platform service, but it's more like a for it's more like a self-service that for users directly. Right, so to prepare for this, I made the assumption that we already have an existing database because most company already have the existing database, right? So with bunch of records to query. For this example, I'm doing or I'm assuming a company that has a subscription-based product that's servicing the Southeast Asia region. So the user could be from Malaysia, Thailand, Singapore, Indonesia, like that. So I have generated the data using the using OpenAI, right? So by using this OpenAI, I generated the data and created the database for this project. So there's four uh, tables, which is subscriber profile, which is more like a user profile. And then we have the subscription where the the user subscription per month records. We have the subscription plan. I only put like three: basic, standard, premium, and the fees. And then also unsubscription or unsubscribes, just to make the the kind of query that we can make varies a bit, right? Okay, so the goal that I'm thinking to achieve by this project is to first is to get to simply get a data set for my own analysis, right? It's more like a raw data, or because could we could also run even analysis directly uh, using the database query, right? So we'll see if we can manage to do that. Right. So again, the way I developed this using the same development workflow, first have the basic idea what to build, and then work with AI to produce the base requirement, and then where we break down the steps to achieve the final output. And then again, look through all the base requirement and then drill down and create detailed plan in pseudocode. And after that, generate the codes to fully implement those detail items in the detail plan. Right, and then we test and we iterate, test and iterate until we get the expected result or reach the expected goals I mentioned just now. Again, using Aider, there are two modes: architect mode, code mode. I think I've mentioned this in previous the video. Right, so let's look at the code. So these are the requirement I generated. First, look at the base requirement. There are three steps here. So first, again, looking at the process flow, we are working on this first part first, making sure that the user and the AI are at the same page on what kind of data that we want to retrieve to be reflected on this, what kind of SQL query to be generated, right? So there's an interactive loop between user and AI to clarify the query intent. And then having the LLM, the context of the schema, the schema that in the database, and then the ability to generate the SQL query and the final SQL query for us to pass to the second step lah. Right. So second step is the database integration the database integration. So where we can run the query that generated from step one, and this should support multiple table and relationship. So that's why we are not using ORM. So I want to make this a bit more dynamic. Not saying that we should not build this kind of system using ORM, because we can, where we actually define all the tables and relationship using codes. But I'm just making this project a little simpler. Right. So again, we are using the schema manager. We're going to expose the current schema to the LLM from step one. Right. So there's a step three. But I'm just saying that, because I don't want this video to be too long. So some of these steps has already been included in step two, and the kind of output is just plain text. But with the data output from the database, we can can easily format it into, like, whatever format lah, PDF, Excel, or whatnot. Right. So I'm using Postgres database, again using raw SQL queries. Then right. So everything else is just what you expect from this kind of project. Right. So there's the how we create the database manager, the database module. Right. So it should be able to establish and maintain database connection. Uh, it can execute any kind of raw SQL queries, and then it can should be able to handle output, result, and also errors, and should be able to provide usable object throughout the session, so that you don't need to connect and connect and connect in one session, right? Okay, so on step one, basically this is the original idea, but I scrapped it. So at first I was thinking to use function call to handle the interaction between user and AI, but I end up thinking that this is a little too, it is very much unnecessary lah. So I ended up doing a direct LLM chat completion type conversation lah, with the user to finalize the kind of query intent for the LLM to be able to generate the SQL query, final SQL query. Right. So then this is basically the detailed plan for the execution. When we have the detailed query, detail or yeah, the final detailed SQL query, then first it will validate the SQL, say, just to make sure that the SQL has no issue with it, and then we'll execute the query and then response, right? So the result, this is basically the format for the return object from this executor class, where there is some sort of summary of the data return, and also how we're going to handle the error. The AI also decide what kind of validation rules. So I just let AI define all this, because to tell you the truth, I'm not an advanced or database engineer. So you know some of this actually goes you know uh, okay, way past my head, because this is a bit too advanced for me. But I have enough experience to know that it works, and the database that the query that has been generated during my test are pretty much in working code lah. Yep. Right. So with that, let's see the codes. So start with the main. So there's function to initialize the system. Once we run it, we need to instantiate the database manager. I mean the database using the database manager. We test some, do some really simplistic tests to see that we are truly connected to the database. Then we instantiate the query processor, which is the class for the step one. And then we instantiate the class for executor, which is the class for step two. Then if everything okay, then we return everything. Then the second one is to process user query, which is basically this first part again. And then only when we have the final detailed query, then we will pass it on to the executor, right? So the idea is, we're going to process the query, and if there's any error, then we're just going to break. If the AIs don't seems to be able to generate the final query, it will return a needs clarification punya status. Then this loop will still continue. And then if the AI is able or have enough information to generate the final detailed query, then it will pass it on to the executor to execute the query. And if there's a result, and it will return in a formatted format. Right. Okay. So, but there's an error. I have created another uh, uh, basically AI instance of process to fix that error. If you look at this, in this execution, it's only be able to fix one time, but we can always just change it to make it a loop to allow if the fixing of the SQL process to be done like multiple times. So we can actually set like, fix this or attempt to fix the SQL like 2 times or 3 times. We can do that by refactoring this into its own function. But for this purpose, I just gonna do like one time. If the query has error, then we're just gonna like try to fix it one time, and if it's okay. If it's not, then I'm just gonna ask the system to just return, I apologize that we cannot generate a valid SQL query, things like that. Right. So the main is basically just initialize the system, and then ask for the input with a loop that we mentioned just now. If the as long as the AI have or don't have enough information, then it will keep asking to further clarify lah. But only if the AI has enough information, then it will break this loop and then go and basically process in this function, right? So on the main, that's basically that's that's basically the process. So the query processor only have two methods. One is actually to process the um, process the query, which is this portion of the processing, and also as another method to fix queries if it happen, right? So let's look at let's simply look at how the system prompt look like. Like I said, we have two goals. One is a simple retrieval. So this one, if you want to retrieve directly a set of data, so that's constitute simple data retrieval. So a query, for example, like saying, give me the last 1 week of August data or whatever. So that is the simple data retrieval. But I've also included an analytical of type query. So if you're looking at If you want to see like patterns, trends, or growth, or whatever else that is not straightforward. So this could also be possible. So uh, because I'm using structure output, so I also state how the output should look like. Yeah, right. So also provide the examples of the simple data retrieval query. So when needs clarification, then this is how the structure output should look like. If you need a confirmation, this is how it should look like. And if it's ready to provide the final detailed SQL, then this is how the output should look like. Right. So if the query is more on asking for analysis, then this is an example that how it should look like. And for pattern, also the same lah. Look like. I did not come up with this example. Basically, again, I'm just asking AI to provide them for me. Right. So there are also notes that the AI provided in terms of how to handle analysis type query, which again is beyond me because this is a bit too advanced. I'm not exactly an advanced database engineer, but because I'm using a good LLM model, so I assume this is all correct. And based on the testing that I made earlier, it looks correct as well. Right. So the instruction, is like this. So first understand the query for simple data retrieval or analysis type or query. So for analysis, do this. For simple one, just generate the query. Right. So and only when user confirms, then the AI will generate the query. Right. So also mentioned that use the PostgreSQL dialect because previously, I didn't add this, and sometimes the AI, uh, not saying hallucinate, but they decided to use a different kind of dialect that actually will cause error when you run it through and build Postgres SQL engine. So I added this as well. Right. So because we are going to talk to a non-technical, so I said always explain things in simple, non-technical terms, talking to user. But the SQL query implements the appropriate method for the analysis. For the data retrieval. Right. So we have only limited to this scope, which is on only on query processing step, which is this portion of the step that we have a conversation history. We could, I could extend this to have a history of the whole thing. In the whole process, but like I said, I want to keep the scope of this, uh, you know, use case project in small. So I just, I only allow, I only, narrow the scope of conversation history just on the step one, right? So put everything in message and then run it through LLM completion API. So we're using the structure output, then we're using the dot parser, and we also provide the response format in a pedantic object that we define up here, which is has the detail satisfied boolean message and also the SQL, the final detail SQL if it gets to that step, right? Okay, so that's that, and then we have the database, the schema, right? So the schema manager is the one uh, going to retrieve the database table, schema information from the database. So I decided to do this instead of hard coding the the database schema on some sort of text that in this project, because I just want to see if we can do this. So this is basically my personal uh, you know uh, preference lah, to include in this project. So again, I have no idea what's going on here, but it looks like the AI is retrieving the schema information and then parse it to get just the table name, relationship, blah blah blah, lah, right? And then provide the output of this processing back to the app so that we can expose it to the uh, to or inside the system prompt here, the schema context, right? So the schema context is basically, yeah, coming from the schema manager where we get schema context, right? So get schema context here, right? And it also has methods to extract table name. This is when we're trying to do the SQL query. I mean, when I want to analyze the finalized SQL query. We want to extract table name so that we want to ensure that the table name is basically uh, basically just this is just extracting, but we also want to compare that with the allowed table, so that the AI won't go and try to query on table that doesn't exist, right? Okay, so that's the schema manager. Then we have the SQL executor, basically, which is the step two, this processing. So this one is basically just the main method for this class is to execute query, basically from the whatever final query generated from step one. Just gonna execute the query and then do some validation, and then if it's successful, go and format the result and return. That's the idea. So validating SQL is against the forbidden keywords that the AI actually defined here. So basically, the idea is when I was working with AI on this class, it did mention that we will want this thing to be a read-only type of application, so that it won't basically damage whatever we have on the existing database. So anything that has drop, delete, truncate, all this will not be allowed in this application, which is good. So I agree with it. Then also going to look at the tables, because we extract the table name, and then we are also going to see whether the table name that we extract from the SQL query is or match the allowed tables. If not, they're gonna that they will just going to flag it as invalid and break from the operation. Right. This is formatting the result again and generating the summary of the data set, and then everything else is just all formatting. Right. Right. So that's all we have in this app for now, because it's kind of like I'm intentionally make it uh, the scope, lit, quite small. So let's look at the kind of let's look at how it works, lah, right? So let's run it. Let's do from simple query to a more complicated one, so that we can see what kind of result we can get, right? And also if those fixing SQL actually triggered or not, because even AI is really good in generating SQL query, but sometimes they messed up. But if we allow them to reflect, then you might be able to fix, right? So let's see. Right. So at first, let's do a very simple one. So let's say, okay. So the looking at the data, I only generated 2 months, which is August and September of 2023, right? So, whatever we ask has to be limited in that time range. Right, so let's do a simple data extraction. So give me data of subscription for first week of August, example, 2023. So I think because this query is quite straightforward, see, if it's if it's quite straightforward, it will just run it because there's nothing to clarify. So you can see that we got the data. So I intentionally do it this way so that you can see the kind of data that has been generated. But we can easily parse this to another method that actually generate a CSV file, for example. So that is also possible, right? So let's make it a little bit uh, complicated. So this one is straightforward. So it's just a simple select. See, simple select. Right. So let's see if we can successfully do a join type query. So give me the names and email of the subscribers on the last week of September 2023. So this one definitely have to join because this thing coming from different tables, right? So if you notice, it actually did a join name and email. Yep, from subscriber profile join subscription, right? On the last week of September, right? So we got the data here, name and email. Okay, good. Right. So let's look at a comparison type query, right? Compare the so compare the revenue of subscription uh, between the second and last week of September, for example, 2023. Will we get an error? This is a little bit more complex. Mm, 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 mm. Okay, no error. We'll look at how complex that query is. Right, so compare the revenue subscription between second and last week. So last week is basically, second week is 8 and 14, and last week is 24th to 30th. Okay, so we are going to sum total revenue as total revenue. We're joining subscription plans, and we got last week is 109, second week is 8 to 4. Not bad, right? Okay, so that is basically a little bit of analytical or analysis type. Actually, not really. This is just uh, still just straight data retrieval, right? Okay, so a more analytical is like subscription analysis, right? Okay, so I don't really know how to put it in a word. So do subscription analysis on uh, or or maybe between August and September 2023. Maybe you will clarify. Oh, got an error. All right. So this is where the fix come in. Oh, we actually managed to fix it. So let's see what happened here. So first I said do subscription analysis between August and September. So we'll try and do this. I have no idea what this is. Right. So it got an error saying that, cannot do round or some sort, right? Because you might need to add explicit typecast. Okay. Right. So the so we pass this error to the fixed SQL query method, which is another LM to try and fix this. It says the error was caused by attempting to apply round function to a double precision, blah, blah, blah. So in Postgres, round typically needs numeric types. So he went ahead and fixed it with this SQL, the new SQL. So, and execute it. And now we got the result. So on August, we got 44 monthly count, and previously there's none, so because there's only August, September. So on September, compared to August, there's a 50% increment of growth rate of subscription. Okay, that's really good. Right. Okay, so let's do one last. Let's look at maybe revenue, right? So show me revenue uh, growth uh, between August and September 2023 uh, for Malaysian subscribers. Malaysian users only. Let's see if we can actually do this. This is really complex. I mean, if I try to imagine, think seriously, that fast, this monthly revenue as like, okay, like I said, I am an intermediate. I have only intermediate database engineering skill. So I this is a little bit advanced for me. So like I said, I can manually double check if this is correct, but looking at the query, maybe you guys can actually give a comment whether this is actually correct or not. I can copy and paste this in the you know in the database workbench or whatever that I'm using, ID SQL. But I'm pretty sure because it's running against the same database, so it's going to show the same result, right? Okay, so run it. Yeah, same result. So like I said, this is probably uh, correct. Right. So on August, because there is no previous month data, so it's zero. But because September can compare to August, so there is a negative 74 0.74% growth rate in terms of revenue. All right, so there you go. This is my use case to show that we can actually build some sort of application that let non-technical uh, you know talk to the or run their own query with the database, whether it's to just get a data set or to actually run an analysis if they have some sort of knowledge or experience with that. Uh, and like I said earlier, that I think we can make this kind of system better or a lot better if we can do some sort of reinforcement learning with human feedback and then attach that or sieve that into some sort of rack system that we can let this process, this step process, to retrieve some sort of contextual information from previous good feedback or good response from user that led to a much better you know SQL or final detailed SQL generation. So with that, I guess that's all for now. So I hope you enjoy the video. Uh, so until next time.